All right, guys, welcome back. And just because I felt like we needed to spend a little more time on it, we're going to go through a factoring review for today, and then I'm going to give you guys a lot of practice with it tomorrow. Today slash tomorrow, I'll have you on a 2-day block so that you can prepare for the factoring quiz that we'll have Wednesday. So let's just get right into it. The think slash moment says, what should be our first step in any problem where we need to factor? And my advice, your first step, whatever you do with any type of factoring, is to factor out a greatest common factor. Every single time, if you can do that, you should do it because it's either going to make it easier and you'll be able to factor it completely in the long run. So today is just going to be a bunch of examples so we can get used to factoring. So factor completely 6x squared minus 11x plus 4. First thing I'm doing is I'm asking, do I see a greatest common factor of those three terms? And I do not. So what I have to do, if we remember when we have something in front of this x squared that's not a 1, we have to multiply the first and the last number. So 6 times 4 is going to be 24. And then if you remember our steps, we need to find numbers that multiply to 24. And we need them to add to this middle number, which is negative 11. Now I'm just running through my head of what numbers those could possibly be. And if you ever have trouble, just list the multiples of 24. Just start listing them. We have 1 and 24. That won't get me there. We have 2 and 12. That's close, but that won't work. And then we have 3 and 8, right? Oh, that looks like that could work if we have a negative 3 and a negative 8, right? Those add to negative 11, and negative times a negative is a positive 24 that it multiplies to. So that's great. So it's those two that work. And now what we do with those two is split the middle. So that's our third step. So splitting the middle means I'm going to rewrite this 6x squared, and now I'm going to rewrite the middle. I'm going to write, and I'm going to use these two numbers. Let me just choose one. I'm going to choose negative 8. And then we're going to put an x after, and now we're going to use that minus 3 over there, and then we have plus 4. And from here, now we're going to factor by grouping. So we're going to look at the first two terms and the last two terms. In the first two terms, I'm asking what can I take out of those first two terms? I see I could take out a 2 and an x from both of those, and what's going to be left is 3x minus 4. And this one's a little tricky because we have another negative here, right? I can't take anything out of 3x and 4, but I don't want this to be negative, so I'm going to take out a negative 1, and that's going to leave me with a 3x. And then once I take out a negative, that's going to be minus 4, right? Because negative 1 times negative 4 is going to be positive 4. So now we have 3x minus 4 and 3x minus 4 matching, which is good. So we can treat that like a single number, and we can pull out that entire 3x minus 4. And then what we're left with is that 2x and minus 1. And that is our final factored form. So now for something like this one, I see two terms, and when I see two terms, I'm thinking it's either a difference of squares, or I just have to factor out a greatest common factor. But our first step is always greatest common factor. So first I'm going to check out these numbers, 15 and 21. Is there anything I could take out of both of those? I think I could take out a 3. That's probably the biggest thing I could take out of both of those. And now I'm going to look at the variables. I have 3 x's here and 2 x's there, right? X to the third means x. It's giving me issues today. X times x times x. And then x squared just means x times x. So they both share 2 x's, so I can bring out an x squared. And then similarly, this one has a single y, and this one has 4 of them multiplied together. So the most they share in common is the single y. And now I'm just going to ask what's left over. 3 times what gets me 15? That's 5. And we have x squared, so we need another x. We already have that y, so we don't need that y. And then we're going to minus 3 times 7 is 21. And then we have the x squareds, and then we're missing 3 of these y's. We need 3 of those y's. And so that would be our final answer. That's just factoring out a single greatest common factor. And now for this one's just a standard one. What multiplies to, since we have an invisible 1 in front of that x squared, what multiplies to 32 and adds to negative 12? And again, if you have trouble, you can just start writing them out. We have 1 and 32. We have 2 and 16. 3 doesn't go. 4 and 8. Oh, 4 and 8 look like they would work if we did minus 4 and minus 8. Those add to negative 12, and negative 4 times negative 8 is a positive 32. So that seems to work. And once we have those two numbers, with a case like this, we can just straight up write them in x minus 4, x minus 8. And again, you could always check your answers by multiplying these back out. So if you multiply these back out and you get what you started with up here, then you know you've done it right. I'm not going to do that for the sake of this video, but on a quiz or something, to make sure you're right, you might want to multiply it back out to double check. So examples, factor completely. This should just, in your head, immediately you should be like difference of squares, right? Because 7 squared is 49. And this one, we're following that rule, and that should just pop off in your head right away that that's 7 plus, or is z plus 7, z minus 7. That one's done. Now here we have another one where we have something in front of this t, and again, first step is I'm going to look for a greatest common factor. Is there one? It actually looks like there is this time. It looks like we could take out a 3 from all of that, and then we'd be left with a 2t squared plus 5t minus 3. Yeah, that's all we can take out of that. So now we still have to, I'm just going to ignore this 3 for a little bit, and I'm just going to focus on this, this long one. So to do that, we have to, again, do the first number, 2 times the last one, negative 3. So we're going to need multiples of negative 6. And we're going to need to add to 5. Multiples of negative 6 that add to 5 are probably going to be, we would need a positive 6 and a negative 1, I think, would be our 2. And then again, we split the middle. So I'm going to, just try and keep that 3 out front. And then we have 2t squared. And then if I have a negative, I'm going to put the negative first. So minus 1t, or just t. And then we're going to have plus 6t. And then the minus 3 at the end. And now, again, we're kind of just ignoring this 3 out front. But now I'm looking for what can come out of these first 2 terms and what can come out of the last 2. And that first one, I see that a t can come out. And then I'm going to be left with a 2t minus 1. And then on this one, I could see a 3 can come out. So a 3 and then 2t minus 1 would be left. And that is a good sign. So now essentially we could factor out this 2t minus 1 and we'll be left with what's over. We have to keep that 3 out front, and then we could factor out that 2t minus 1. And then we'd be left over with t plus 3. And that would be our final answer. And then this last one might be a little tricky, right? There's 2 terms, so I'm either thinking it's just a greatest common factor or it's a difference of squares. I don't see a greatest common factor. of either of those, but I bet it's a different of squares then. But how would we do this? And this one is where you really have to recognize that it's something squared minus something else squared. And in this case, it's going to be 6x squared minus y cubed squared. Does that make sense, everyone? Because think about this. What does squared mean? Squared means something times itself. So 6x times 6x. Wouldn't you agree that that is 6 times 6 is 36, and then x times x is x squared, right? And then here we have y cubed squared, which really means y cubed times y cubed, which if we were to write that out, that would be y times y times y times y times y times y. Y times itself 6 times, which is y to the 6th. So that works, right? So now this is our a and this is our b that we just have to think about, right? And that a minus b, a plus b. So that would make this 6x minus y cubed, 6x plus y cubed. Those ones just take a little bit of extra thought in recognizing that it's something squared minus something else squared. And this last one, I thought I would just do to work on our ability to problem solve. This one's just a little more in depth, but if you can just follow the process correctly and do the computations right, you'll get there. So first things first, is there a greatest common factor? And yes, there is a greatest common factor. Immediately that I see is 3, but I think there's another one in this one. They each have an x, don't they? So after that, we would be left with a 2x squared plus just an x, and then a minus 10, right? Because if we were to take that 3x and throw it into everything in there, then we would get this back, right? 3x times 2x squared is 6x cubed. 3x times x is 3x squared, and then 3x times minus 10 is minus 30x. So now we can just, again, kind of just keep this 3x out front and focus on this. And again, it's one of those where we're going to have to break it up. But at this point, you could follow your steps and you'll get there. But I'm just going to think about it, right? So 2x squared, I know that the only multiples of 2 are 2 and 1. So I know one's going to need to be 2x, and I know the other is going to need to be x. And I see a minus at the end. So one has to be plus and one has to be minus. We just have to figure out which one it is. And they have to be multiples of 10. What are the multiples of 10? We have 1, 10, 2, and 5. And that's it, right? So we only have a certain number of combinations with this one. But we have to be careful because of this 2x here. Well, let me just pretend to throw something in, right? If I were to throw, I know I'm going to need a minus, let's do the minus 5, and then the other one would have to be a plus 2. We know we need a plus and a minus, and we know it needs to be one of these two combinations. And let's just think about that. If we did that, then I would get 2x times minus 5, which is minus 10x, and then plus 2x. That would give me negative 8x, so that doesn't work. Oh, well, let me try switching these around, right? What if I did plus 5 here and minus 2 here? Does that work? I don't get 10x minus 2x. No, that doesn't work, right? So we have to keep going. That doesn't work. Oh, look at this. What if I do plus 5 here and then minus 2 here? Because then 2x times negative 2 is going to be minus 4x. And then 5 times x. So 2x times negative 2 is going to be negative 4x. And then 5 times x is going to be 5x, which together just equal a single x, which we have up there. So this works, right? And, you know, if you're having trouble seeing that, don't worry. Just follow the process that we've done for, ones like these, where we have to do this thing off to the side and then split the middle. Just follow that process. I just thought maybe I'd show you guys that it's possible to think about these ones. It could just be difficult, especially once you get like a 6x in there or something where you have, it could be 6 and 1 or 2 and 3. But yeah, so if you followed out all the steps, this is the answer. You would get the same answer. So that should do it for our factoring review. I know it was quick, and I know we just pounded out some examples, but I think at this point, that's just kind of what we needed. After Wednesday, we will move on to functions.